Greetings of the day. Uh, my name is Dr. Lipeeka Rout, and I am working as an assistant professor in Department of Chemistry, Madanpalli Institute of Technology and Science, Andhra Pradesh. So today I am going to speak on a topic that is Introduction to Nanoscience and Nanotechnology. So in today's topic, I will be covering up about the introduction of nanoscience, their history of nano, where the word nano came, what are the different application of nanoscience, what are the different properties, why nanoscience is preferred over bulk materials, and I will also discuss about the applications in various fields. So before going to the main topic, we will understand about some definitions of nanoscience and nanotechnology. So first thing is, what is nanoscience? So as the terms itself suggest, nanoscience. So there is the mixture of two terms. One is nano and another one is science. So basically, this nanoscience deals with the building up complex material and machines using fine control on matter at nanoscale regions. So basically, what does that mean is, so here in nanoscience, basically we study about the matter at atomic scale or at nanoscale. Then again, the study of materials and their properties at a length scale of few nanometers is known as your nanoscience. So any materials which will be having a scale range length of few nanometers and their properties when we study, we call it as a nanoscience. Now coming to the another point, another definition, that is your nanotechnology. So, as we know, nanoscience is applicable in many applications, either it is in physics or it is in chemistry or it is in maths or biology. So, the technique involves in the preparation, characterization, and use of the properties of this nanomaterial in different applications are collectively known as nanotechnology. So here you can see there are certain scale it has been given. If you compare this nanoscale with other scales such as meter or centimeter, so in that scale you can see how the size looks like. So in this particular thing I can explain in the next few slides. So now coming to what are nanomaterials. So nanomaterials are having unique properties arising from their nanoscale dimension. So as we all know, there are three dimensions in space. One is x-axis, y-axis, and z-axis. So where in all this direction, if any material is having this all nanoscale region, their length in all this direction, that is known as your nanoscale dimensions. And also nanomaterials have extremely small size which have at least one dimension to 100 nanometers. And depending on the application where you are using this nanomaterial, their size differs. So basically, if you are using any nanomaterial in catalysis point of view, catalytic application, in that case, the nanomaterial should be in a range of below 10 nanometer. But in the same time, when you are using some nanomaterials in absorption thing or photocatalysis application, in there you have to make synthesize a nanomaterial at a range of 100 nanometer, 100, 200 or 300 nanometers. Another thing is 1 billion nanometer is always equals to your 1 nanometer. If you compare the nanometer to a meter scale, then 1 millionth of the nanometer is always equals to your 1 meter. So now coming to this slide, so you can see here, we are having a nanoscale and microscale region. So we are having a nanoscale and microscale region, so which suggests that in the nanoscale, if you will see, so there is we are having nanomaterials, small particles, atoms, and molecules. But in the same case, in macromolecules, like for example, plant cells, DNA, or your hair strands, so those are comes into macro scales. So now coming to the main point, why nanoscale materials are preferred. So nowadays, nanomaterials are having enormous applications in various field, whether it is biological field or engineering field or other applications. So why we are preferring nanoscale material? So first thing is it is clean, secured, and affordable energy. So nanomaterials, because of their very good properties compared to their bulk particles, they are preferred to be more clean, secure, and they also carry affordable energy. They are stronger, lighter, and more durable materials. And also, they can be used as low cost filters to provide clean drinking water. And these nanomaterials in various medical field also we can use, such as in drugs, to detect the treat disease more efficiently with fewer side effects. So basically these nanomaterials, when we use in medical field, we observe some fewer side effects, like lighting fractions that uses a fraction of energy, sensors to detect and identify harmful chemicals or biological agents. So basically, we can use these nanomaterials or nanocomposites for sensing application, where we can sense any harmful gases present in water, in air, or any harmful like liquid presence in water. So those which are affecting the environment. So those gases or those liquid we can detect from nanomaterials. And these techniques are to clean up hazardous chemical in environment. Also in many application field, like for example photocatalysis, so there you can use these nanomaterials as a catalyst, so that it can absorb all the harmful chemical inside this, and you can get a pure form of the water. So this is why we prefer nanoscale materials over the bulk counterparts. So there are certain properties of the nanomaterials which makes them a ideal candidate or ideal material for many applications. So that we will discuss in next few slides. Okay. So before that, what are the, like, there are basically 10 factors or 10 things which we should know, which we should be aware of nanoscience and nanotechnology. So what are those? First thing is the concept. So first thing we should know from where this concept nanoscience and nanotechnology comes from. So just like briefly I can tell that concept came from a famous physicist. His name is Richard Feynman. Then next thing we should know about the definition and usage of the term nanotechnology. So what is nanotechnology? Where we use this term nanotechnology? So that we should be aware of. Then what is the special thing about nanotechnology and why it is an issue now? And the third thing we should be aware of is what is the most special thing about this nanotechnology? Why in recent times we are using nanotechnology in many applications, and why this is a very broad area of research that we should know. At the same time, there are some issues also there which is associated with this nanotechnology, that also we need to address it properly. So the one simple issue I can tell about this nanotechnology is the some nanomaterials, when we use it in a drug delivery applications, it may get into our blood cells, and it can have some hazardous effect for our health. So though like that, there are so many disadvantages of nanotechnology. So that also we need to understand, and we need to address those things for better efficiency of the composites. Then next thing is the new materials. Like with nanomaterials, we already discussed it is nanomaterials is having a length of few nanometer. But in this recent times, what are the new material which came in this category? So there are like carbon nanotubes are there, graphene are there, then fullerenes are there. Like this, we have certain carbon material which are also known as nanomaterial, which have shown many applications in different areas. Then next thing we should know about the nano manufacturing, how we can synthesize. So this is a very important part, like how we can synthesize this nanomaterial. As I said, when you are going to synthesize any like catalyst thing, in that case the nanoscience range will be different. But if you are going for some other application, some industrial application, then that case the nanocomposite nanomaterial size should be different. So the size of the nanometer, whether it will be 10 nanometer, 20 nanometer, or 100 nanometer, that is all depends on the synthesis conditions, like which method we are preferring over the for the synthesis of that particular nano composites. So this nano manufacturing is also important for the nanomaterial synthesis. The next thing is some numbers like investment papers and patents, then we should like nowadays the research over this nanomaterial is really very broad in the research area, and we are getting so many patents regarding the nanomaterials for water purification, nanomaterials for sensing applications. Then we have to invest in such a, like if you are getting some kind of product which is actually useful for environmental application, so we should invest some money to bring some project or so to build up some kind of devices which can be useful for the environmental application or energy storage application. Then next thing is another thing about this nanoscience is your commercial application. So we can't stick till until the lab scale. We always have to think about the commercial application of any nanocomposites we are synthesizing. Like why, like if you are getting an good efficiency in lab scale, so you should be sure that in the commercial scale also it should be helpful or it should show the same application. Then industry example, energy sector. So then what are the like usage of this nanomaterial in industry sector or in energy sector? Because nowadays in India or in all over the world, the energy sector is growing really high. So we should know the application of this nanomaterial in energy sector as well. Then the risk factor, as I said, what are the risk, like what are the risk of using this nanomaterial, what can be the disadvantages of this nanotechnology. So those things also we should address, and we should try to like solve those issues. Then societal aspects, like how the society will accepts the usage or the importance or the advantages of this nanoscience. So these 10 things are really very important when we are going into nanoscience and nanotechnology. Then coming to the concept. So what is the concept behind that? What is the main concept behind the nanotechnology? So nanotechnology is science, engineering and technology conducted at nanoscale, which is about 1 to 100 nanometer. So like it's generally generalized way I'm telling it is 1 to 100 nanometer. And the study and use of incredibly small objects is known as nanoscience and nanotechnology. So where any subject where we study about the synthesis, about the properties, about the application of incredibly small objects, that is known as your nanoscience and nanotechnology. And it has application in other branches like in the science, including chemistry, biology, physics, materials engineering, metallurgical engineering, civil engineering, etc. So basically this subject nanotechnology, it's not just a subject in science, but it's a novel area of science and engineering, but also a fresh perspective of the subject. So because it is like nowadays nanotechnology is having so many applications that now it is becoming a broad area of as a subject in science and engineering. So what are the different fields of nanoscience and nanotechnology? So here I will show you. So see, you can see in nanoscience, if it in coming to the application of biology, it can be in different application of nanoparticles like biomedicine, microbiology. Similarly, in physics, you can use in optics, laser, and plasma, like that you can do by engineering, XRD, SEM, and AFM. In coming to the chemistry field, you can be using in metal nanoparticle can be prepared, carbon-based nanomaterial can be prepared. Then it can be used in like electrochemistry, catalysis, sensor, and material science. So these are the different fields of nanoscience and nanotechnology, in which comprises of chemistry, biology, and physics. Now coming to how it all started, like how this concept, this nanoscience concept has been started. What is the origin of this concept? So the idea and concept of this nanoscience and nanotechnology started with a talk, which is named as "There's Plenty of Room at the Bottom." So this talk was given by a physicist. Its name is Richard Feynman at the California Institute of Technology on December 29, 1959. So basically, in his topic, he described that as a topic itself suggests, there is a plenty of room in the bottom. So where we are standing on the floor, the object, there are many objects we can see by our eyes, but there are so many objects or so many rooms are there, so many particles are there, which we can't see by our naked eyes. So those, he has compared those things to towards the nanomaterials. So after his talk, over a few decades, it has explained in the ultra precision machining. Professor Nario Taniguchi coined the term nanotechnology. So when those nanomaterial was interacted with the machining technology, that term is given as nanotechnology by the scientist Norio Taniguchi. Then after that, in 1981, when there is a development of STM. So STM means scanning tunneling microscope. So this microscope allow us to see the exact number of atoms, the particles, okay, and that could see individual atoms. That from there itself, the modern nanotechnology begins. So basically, after 1981, after the development of STM, the modern nanotechnology, what we are considering till now, till date, is came after the 1981, but the concept is been started at 1959. So this is the history behind nanomaterials. So then what is nano? So basically nano comes from a Greek word which means dwarf. So we all know dwarf means small. So the prefix nano means a factor of 1 billionth and can be applied as to example time. If you are applying this nano to time, it is nanosecond. Then nanoliter if you are applying to weight, and nanometer if you are applying to a length. Then it is popular to use nano refers to length of nanoscale, usually refers from atomic level towards 1 to 100 nanometer. So basically any material which will be having a size range of 1 to 100 nanometer is known as your nano materials. So this nanostructure or nanomaterial are form of matter at nanoscale. So whatever we are discussing till now about the materials, they should be nanoscale, right? So if you compare these nanomaterials to a sheet of paper, so a sheet of paper is about 1 lakh nanometer thick. For example, if you compare this human hair, whatever hair the human are having, the human hair is around 80,000 to 1 lakh nanometer wide. The radius of this human hair is that much nanometer. So it is a very interesting fact is also associated is that your fingernail grows about 1 nanometer per second. So every second around 1 nanometer of our fingernail used to grow. So this is about the basics of nano. So next thing is why it is so special. Why nanotechnology or nanoscience and the nanomaterials, why it is so special? What are the basic property or what are the most important property of that? So first thing is that materials can have different property as nanoscale. That is your quantum effect. So what is this quantum effect is? The quantum effect is when the size of the nanomaterial is smaller than compared to the de Broglie wavelength. That is your quantum effect. So in this case, what happens? Some nanomaterial will be stronger. Some have different magnetic qualities. Some reflect light better than like other bulk materials with size change, and other are better at conducting heat or electricity. So basically there are some certain kind of nanomaterials because of their optical property, and they show different colors at different size range. So that is the first effect, that is a specialty about this nanotechnology. Then additionally, compared to the comparable volume of large scale materials, nanoscale materials have considerably big surface area. Big surface area means it can absorb, or it can there are more active site are available for interaction with other materials, other like catalysts. For example, if I'm having a nanomaterial of gold nanoparticles, so if I'm doing catalysis of that, so the gold nanoparticle will be having larger surface area compared to the bulk parts. So in that case, what will happen if it is having large surface area means it is having more active sites. So if it is having more active sites means the reactant molecule will diffuse more on the nanoparticles. So this is the about the speciality about nanotechnology. First thing is its surface area, and another thing is quantum size effect. Then coming to the various properties of nanomaterials. So first and foremost property, important property of nanomaterials is its surface to volume ratio. So this is the important property. So nanoparticle of material shows different property compared to the same materials. So here you can see I have given one example. So for example, this is an bulk particles, and this is the nanomaterial. So this is a cuboid, and this is also a cube. So you can see here how many sites are there? 3 sites are there. Okay, here also three sides are there, but here it is one side is there. Then if you calculate the like surface area and volume of this all cube, you can see, if you'll compare the surface to volume ratio, you can see here where there is only side one, when the size is smaller, the surface to volume ratio is more compared to the other two. So this particular thing shows that when there is high surface to volume ratio is there, that means more active sites are present for the particles to like interact with other materials. So the forces of attraction between surface can be appear weaker on larger scale, but on nanoscale they are stronger. Right, correct. So this is an example of, and this is an important property of the nanometal, that is your high surface area to volume ratio. Then there are optical properties. So when we are discussing about the optical properties, we should consider about the band gap. So we all know the band gap means like the band gap defined about the properties, whether it is a semiconductor, whether it is a conductor, or it is an insulator material. So band gap is the energy separation between conduction band. So we are having two bands, one is conduction band and one other one is valence band. So here you can see when the difference between this conduction band and valence band, that is known as energy gap. Energy band gap is this very small, this is semiconductor. But once you go from a bulk particle to nanomaterials, you can see the energy gap is increasing, means the band gap is increasing, means it is going towards a insulator. Okay, so as we go in nano range, number of atom decreases to 10 to 1000 atoms, so energy state decreases and band gap will be more. So this is another optical properties, or you can say the band gap properties of nano materials. Then coming to the magnetic properties. So the magnetic properties will suggest us whether your material is magnetic, paramagnetic, diamagnetic, super paramagnetic. So those kind of magnetic behavior we can also detect from this nanomaterials. So basically for nanomaterial, important consideration is interaction among exchange energy and diamagnetic energy. So basically here you can see this particular figure, you can see about the graph between the coercivity and particle diameter. So more the diameter, the magnetic behavior is also increasing. So you can see here for the smallest one, the magnetic behavior is super paramagnetic region. But when the size of the particle is increasing, it is going towards ferromagnetic region. Similarly, if you consider the hysteresis loop, so basically hysteresis loop will show us what kind of magnetic behavior your material is showing. So here you can see the hysteresis loop also show, like if it is in straight line, it will show either it is diamagnetic or paramagnetic. But if it is in the shape of this, it will be ferromagnetic, and if it is in shape of a single line, it is a super paramagnetic behavior. So by this also we can say, depending on the size, and if you compare the bulk material to nanomaterial, their magnetic property also changes. Now coming to the electrical properties of nanomaterials. So basically the electrical properties of nanomaterials based on four mechanisms. First is your surface scattering, change in electronic structure, their quantum size and effect of microstructure. So basically the electrical properties of nanomaterials will decide about the electronic application usage in the nanomaterials. So what are the changes you observe when the nanomaterials, will you synthesize the nanomaterial from the macro scales? So the property change of nano at nanoscale, for example, if you are going for copper nanoparticles, in macro scale, the copper materials are in opaque, but when it comes to the nanoscale, it will change its structure and it will come towards the transparent range. In platinum, in macro scale, it is inert in nature, but in when it comes to like nanoscale, it is in catalytic nature. Like for example, in recent research, in many organic synthesis, we are using platinum nanoparticle as an catalyst to speed up the reaction. Aluminium, when it is in macro scale, it is in stable state, but when it come to the nano scale, it is in combustible in nature. Similarly, silicon in scale it is insulator, but in nano scale it is considered as a conductor. So these are the effect of properties in the macro scale range of the materials and to the nano scale. Then coming to the type of nanostructure. So on the basis of the dimension of the materials, the nanostructure are divided into four categories. First is your zero dimension, second one is on one dimension, two dimension and three dimension. So, what is the zero dimension nanomaterials? So, the zero dimension nanomaterials are those in which all the three dimension are in nanometric range. For example, nanoparticles or well separated nanopowders. So, those particles which will be having, they will be having all the dimension in a nanometric range. So that's why they are considered as zero dimension nanostructure. Then one dimension in which only two dimension are in nanometric range, but the other one will be in the larger than the other the next two. So that is your nanotubes or nanorods. Then two dimension nanomaterials in which only one dimension will be nanometric range and the other two dimension will be larger than the other one. So that is, for example, nano thin films, the nano layers. So those comes under two-dimension nanomaterials. Then for three-dimension nanomaterials, all the dimension are outside the nanometric range. That means those will be considered as nanomaterials, but their size in the different dimension will be more than the nanometric range. For example, group of nanowires, group of nanotubes, etc. So these are the classification of nanostructure on the basis of their like dimension. Then coming to the another important factor of nanomaterial, that is your nano manufacturing. So because as I said, if you are going to for different application of nanomaterials, you should understand what size of nanomaterial will be using, will be applicable for what applications. For that, nano manufacturing is very much important. So basically, nano manufacturing is having two different approach. One is top down approach and another one is bottom up approach. So this is the pictorial representation which shows the top down approach, where you can see they have taken a bulk material, they're transforming by energy into a small powder and further transformation to smaller fragments towards the nano materials, nanoparticles. Similarly, for bottom up approach, they will be taking a precursor which contains atoms or molecules, and by formation of ions or radicals and in condensation by clusters, then it can be synthesized towards the nanomaterials. So basically, bottom up approach involves the miniaturization of materials components up to atomic level with further self assembly of particles. So basically it starts from the smaller particle of molecules or atom, and there will be self assembly, like together they will self assembly and they will form the nanoparticles. So during the self assembly, the physical forces operating at nanoscale are used to combine the basic unit in larger scale. So larger scale, it doesn't mean it will go to the macro scale, it will be in the nanoscale only. It will start from the atoms to nanometers. Then in case of top-down approach, this approach uses larger particle which can be externally controlled in the processing of nanostructure. So typical examples are etching through the mask, ball milling, and application of severe plastic deformation. So this is about the bottom-up and top-down approach process for nano manufacturing. So what is the another differences between bottom up and top down approaches? So basically this bottom up approach, basically in the lab scale, we normally we use this bottom up approach method. But when you go to the industrial scale or in engineering field, we use the top down approach. So in bottom up approach started with atoms or molecules and build up to the nanostructure. And this use of this bottom up approach is very less expensive. But in case of top-down approach, it begins with pattern generated on larger scale, then reduces to the nanoscale. First, we have to generate in a larger scale, macro scale, then we need to slowly reduce it to the nano scale. Then by nature, they are not that much cheap, and also we need very expensive instruments to perform this kind of synthesis method. They are slow and not suitable for large scale production. So basically, this top-down approaches is not suitable for large scale production. Now coming to the one type of nanometal, that is a metal nanoparticle. So basically metal nanoparticle are zero dimension nanoparticle. So nanoparticle comprised of a metal that ranges from 1 to 100 nanometer roughly. So I'm not saying like if you are going for 200 nanometer, it is not a nanometer. No, that is also a nanoparticles, but it depends on which application you are using it. So basically, this nanoparticles exhibit specific physical and chemical property due to its quantum size effect. So again, there is a term, it is known as quantum size effect of the at nanoscale, means the size of the it will be smaller as the size of the de Broglie wavelength. A special property of nanoparticle is its high surface area to volume ratio, and thus are involved in the reaction. So it have high surface to volume ratio in such a manner that it has a more active site which can be used in catalytic applications. So basically, nanoparticles are of two types. One is monometallic and one is bimetallic nanoparticles. So monometallic means those nanoparticles which are made up of only single metal source, and bimetallic which is made up of two metallic sources. So in this particular slide we will discuss like why this bimetallic nanoparticle are preferred over monometallic nanoparticle, and what are the efficiency of this bimetallic nanoparticle. So what are these bimetallic nanoparticles? So as I said, it is made up of two precursor of two metals. So it is consisting of two different metals to improve catalytic activities and selectivity for many systems. The higher activity and selectivity of bimetallic nanoparticle are compared to those of monometallic are typically attributed to the ensemble and electronic effect. So when there are two metals are there and we are combining this, obviously the property will enhance, right? So considering this bimetallic nanoparticle, it has many structures, but most general and most important structures are like types of bimetallic structure are random alloy, core shell structure, and cluster in cluster nanoparticle. So here this is a alloy structure. You can see here two metal are there. They are randomly they are mixed and they are present in the nanomaterials, nanoparticles. Core shell, in this core shell there will be one metal will be sits in the core and other will be surrounding that. So this is the core shell bimetallic nanoparticle. Then cluster in cluster, there will be one cluster of one metal. If for example you are having two nanoparticles, one is made up of A metal and another one is B metal. So first cluster in cluster means first atoms will be of metal A, then metal B, then metal A. Then there will be arrangement in a series. So that is your cluster in cluster bimetallic nanoparticles. So now, why this bimetallic is preferred over monometallic nanoparticles? So what is the motivation towards using this bimetallic nanoparticles? So there are basically two most important motivation. One is your synergy point of view. Like in synergy point of view, what is this mean is this bimetallic catalyst will improve the qualities compared to the distinct metallic components. Because of their electronic effect, when we use this bimetallic nanoparticle compared to the monometallic, it will show higher efficiency. Then another property is their economic point of view. For example, if you are having there are certain metals which are expensive, but there are some metal which are not that expensive. So if you can mix both of them, then you can, if you can get a good catalyst, then it you will save some money. So in the economic point of view also, bimetallic nanoparticle is preferred over monometallic nanoparticle. So what is the chemistry with bimetallic nanoparticle? So the major challenge, or you can say the major challenge or major issue what we face while using this bimetallic nanoparticle is the characterization. So what is characterization is, so whenever whether this material has formed or not, we need to know their properties, we need to know their structure. We do the characterization by using some sophisticated instrument. So the major challenge of this bimetallic nanoparticle is their characterization. So it is very difficult to find know the properties by the characterization methods. So how can you fully characterize a bimetallic nanostructure even if you are not able to synthesize it? That is how you do know you made it. So complex structure. So some complex bimetallic nanoparticle you can't measure, you can't characterize with small instrument like UV or FTI. You always have to go for better instrument such as scanning electron microscope, transmission electron microscope, etc. Then next thing is synthesis of bimetallic nanoparticle. So bimetallic nanoparticle is mostly synthesized by two methods. One is co-reduction method and another one is sequential reduction method. So in co-reduction method, the two metallic salt are simultaneously reduced in the presence of a stabilizer. So why we are using the stabilizer is the stabilizer will help to prevent the aggregation of the particles. That's why we are using stabilizer. So stabilizer can be any polymeric material to form the corresponding bimetallic nanoparticle. So in this what will happen is we have to take both the metallic salts, metallic precursor, and simultaneously we will reduce it to get the nano materials. So particularly using this co-reduction method we get this alloy structure. Then next one is successive reduction method. So successive reduction method in a second metal is grown on the surface of pre-formed metal nanoparticle. So if you are having two metal precursor A and B, so in case of co-reduction method, you have to take both the precursor A and B in a single flask, and then you have to reduce it by using a stabilizer, and you will get the nanoparticles. But in case of sequential reduction, first you will take the metal A precursor, then you reduce it, then you have to add the metal B to get the nanoparticles. So in that sequential reduction method, when we use, we mostly there is chances to get the core shell structure of the nanoparticles. So basically these are the two method by which we can, most important method by which we can synthesize the metal nanoparticle, bimetallic nanoparticles. So now coming to the various application of nanomaterials. So as I said, depending on the size of nanomaterials, we can use it in different applications. So what are the application we can use in semiconductor industries, paints, cosmetics, drug delivery application? So when you are coming to the drug delivery application, so there will be like the size of the catalyst should be small. The nanoparticle should be in the range of 1 to 10 nanometer. Then in medicines, then in biosensor for sensing different gases or different different vitamins or different components in our body. Then catalysis for any organic catalysis we can use. Then automobiles, then electronics and agriculture. So these are the application of nanomaterials in different fields. Thank you for listening.